Hello everyone, welcome to School Math Simplified. Here we are doing chapter 4 quadrilateral. This is last figure it out. So without any delay, let's proceed to the question number 1. The question number 1 is find all the sides and the angles of quadrilateral obtained by joining two equilateral triangles with sides of length 4 centimeter. The question you need to find out all the sides and the angles with the from the figure that is obtained by joining two equilateral triangles. So here is the possibility of the figure. So this way you can join two equilateral triangles, and this way you will get all the sides. This is 4 centimeter, this is 4. So this also will be of 4, this also will be of 4. So sides will be of 4, right? This is clear. All sides all sides will be 4 centimeters. So now about the angle, right? As you can see the angles also, angle A, we'll count the whole angle A. So 60 plus 60, this is 120, right? So angle A is equals to 60 degree plus 60 degree, that is 120 degree. Angle B is 60 degree. Angle C is again 60 plus 60. This is 120 degree. And lastly, angle D. Angle D is of again 60. About the answer of your first. I hope this is clear to you. Moving to the next question. Next question is construct a kite whose diagonals are of lengths 6 centimeter and 8 centimeter. We are given with the diagonals of it. So for this, let's draw the diagram. Here we first draw a line segment of length 8 centimeters. As one of the diagonal is given, the line segment AB, which is of 8 centimeter. And now take a point P on the line AB and draw a perpendicular line to AB which is passing through P. Draw a line on AB. And for the perpendicular line, you can use this also. You have other ways also. So I'm using this for the line. Point at 90 degrees. You can do it. Okay. Here 3 centimeters. But we can get the exact length. Now name it accordingly. Say this is C, this is D. Overwriting. Now nothing, just join A, B. All the points should be joined. Please mark a sign of 9. Let's join it. So this will be the kite. We are here is the point P on this line can be taken anywhere, but there is no such condition. One line is there, which is splitting AB, is splitting AB into two equal parts, ED into two equal parts. So the requirement of point P is not at the middle, it can be taken anywhere because we are creating a kite here. This is also correct, this is also correct. This is one of a kind which is we are presenting that it could be look like this also because there is not mandatory to take the at the middle of A. But yes, there is one provision that the line CE will be bisected by line AB. This thing should be in your mind. This should be 3 3. This meant. Yeah. So moving to the next question. Question number 3. Find the remaining angles in the following trapeziums. You have two trapeziums, you need to find out the other angles of the trapezium. Do it. Question number 3. So moving to the first figure, you are given with two parallel sides. So say this is A, B, C and D. You are given AB is parallel to CD. This is given to you, this figure, right? And angle C and angle D are given. This is 105 and this is, as I have told you earlier, in if two lines are parallel and one transversal line is cutting, so the sum of the interior angles is of 180. Similarly here, AB and CD are parallel and BC is a transversal line. So angle B and angle C, the summation of both the angles will be of 180 degree because they are co-interior angles leading to 180 degree. Angle B is yet to find, plus 105 degree is 180. So angle B is equals to 75 degree. Yeah. And similarly with this, similarly you can find angle A. For this angle A plus angle D is equals to 180 degree. Angle D will be of 180 degree minus 135 degree. It is leading us to 40. And in this figure, you are given only one, but you are given another thing. Sides are equal. Two sides are equal, and we are given isosceles trapezium. Isosceles trapezium is isosceles. So, if we are taking it as A, D, accordingly, angle C and D both will be equal. Angle C is also of length of measurement 100. Now again apply the same formula as angle B and C both are co-interior angles. So angle B plus angle C, they are of 180 degree. This is leading us to 80 degree. Angle B is 80 degree. Again, if angle B is 80, angle A will also be of 80 degree. Why? Because angle D is also 100 degree. Moving to the next question. Question number 4. Question number 4 is draw Venn diagram. Venn diagram we discussed showing the set of parallelograms, kites, rhombuses, rectangles, and squares. Then answer the following questions. The questions are like this. What is the quadrilateral that is both a kite and a parallelogram? Can there be a quadrilateral that is equal? And then lastly, is every kite a rhombus, or if not, what is the correct? So moving to question number 4. So this will be the diagram, Venn diagram for all these kites, parallelograms, and rhombus. As we know, every rectangle, I'm using short words here, every rectangle is a parallelogram, every square is a rectangle, and every square is a rhombus, and every rhombus is a kite. This is what we know, right? So look at the Venn diagram. The question number 1 was what is the quadrilateral that is both kite and parallelogram? You need to answer a figure which is both kite and parallelogram. So is the you can see kite and parallelogram. These are parallelograms and these are kites. So the common area is of through the Venn diagram. When we have two things intersecting, so this area is showing that it is having both the properties, one and this one. So here set of rhombuses according to Venn diagram. The answer of one is set of yeah. Question number 2. Can there be a quadrilateral that is both a kite and a rectangle? So a quadrilateral which is both a kite and rectangle. So rectangle is this, kite is this, so there is nothing common, right? So one figure is this, and one figure is uh, this, this area and this area. Nothing is common in them, so the answer will be no. Nothing is common. Will be third part. Third part is every kite a rhombus? If not, what is the correct relationship between the types of quadrilateral? So the answer will be every kite is not a rhombus. Every kite, so this kite, this is no rhombus. As you can see, this is a portion of kites. This is a portion of. Can you see that every kite is a rhombus? No, there are some of them are right. So the answer again will be no. And what is the correct option for this? Correct option for this is every rhombus is a kite. इसका उल्टा. So it will be correct option is every rhombus is a Okay, moving to question number 5. That is, if pair and rods are two rectangles, you need to find angle IOD. So let's do it. You are given two rectangles and you are required to find a particular angle. So how will you do it? Fine. So this is what we are given with. We are given with pair, PAIR, and rod, and this rods, right? So these are the two rectangles are given. Rectangles are here, okay? And you need to find out IOD. That means you need to find out this angle. Are you clear about the question? You need to find out IOD. This angles to be find out. For this question, you are required to draw a construction. The construction will be you need to draw a line OK. Okay, this is a line. It should be straight OK, which is parallel to RI. That means the construction part would be, आपने क्या construction करनी है? You need to construct OK parallel to RI. This is a construction that is done by us, right? Now look at here. Angle KOR, this angle KOR, right? And angle ORE, this one. These two angles. Can you see that? This angle, angle 1, and this angle 2. These two angles are equal. How they are equal? Because they are alternate angles. Can you see the Z here? Right? So they are alternate angles. Angle 1 equals to angle 2. That means we can write it as angle KOR equals to angle ORI, which is 30 degree. So what angles are they? They are alternate interior angles. Okay, and KOR and ROI, that means this angle. This is angle 3. That means angle 1 and 3. Angle KOR plus angle ROI. They both are adding up to 90 degree. As you know, this is also 90 na, because they are rectangles, and if this line is parallel, so this angle, the whole angle will also be of 90 degrees. So angle 1 plus angle 3 is 90 degree. So from here we can easily find out angle KOR, right? So angle KOR is equals to, which is 30 degree. Sorry, we can easily find ROI, right? So 30 degree plus angle ROI is equals to 90 degrees. So this is giving us angle ROI equals to 90 degree. Sorry, 90 degree minus 30 degree. So this is 60 degree. Angle ROI is 60. That means angle 3 is 60 degree. Angle 1 is 30 degree. This is quite obvious also, and you can deduct it also, okay, deduce it also. Now ROI and IOD, just this ROI and IOD, they are also of 90 degree. Can you see that? This whole angle ROI and angle IOD, this is also summing up to 90 degree. Why? Because rod is this is also a rectangle, right? So this angle summing up to 90 also. Now you have ROI, the measurement of ROI is 60 degree. IOD, that what we need to find. Angle IOD will be 90 degree minus 60 degrees. So The answer will be of 30 degree. That's all. This is what we need to find, right? So angle IOD is equals to 30 degree. We just use the property of rectangle, that is all the angles are of 90 degree. With the help of that we find the angle. Yeah. So moving to the question number 6. Question number 6 is, construct a square with diagonal 6 centimeter without using the protractor. Now we will not use the protractor, we'll use the compass here, and we are required to construct a square in this case, and we are given with only diagonal. Fine. So let's do it. This is the sketch, actual sketch. This is actual sketch. Okay, and I will tell you how we will draw it. Okay, so let's do it. We need a compass and we need a ruler. So firstly we will draw a line segment of length 6 centimeter. We are going here, line segment of length 6 centimeter, and call it as AB. This is AB, which is 6 in centimeter. Yeah. Now you need to use the protector, compass. We'll use the compass. Okay, see, we will open the compass of length 4 centimeter. It should be more than 3 centimeter, right? So we will, like this. And you know, it will be on both the sides. It will be on both the sides from A. Now from, yeah. So I'm explaining you again. First, you need to draw a line segment AB of 6 centimeter. This is of 6 centimeter. And you need to draw these arcs. It should be radius more than, the radius of the compass should be more than 3 centimeter. The half of this, right? More than 3 centimeter. 6 का half कितना होता है? 3 होता है. So we will open it more than 3 centimeter. After joining the points, we'll make sure that the line above the center point should be 3 centimeter. We will mark a point here. It should be of 3 centimeter, and down also it should be of 3 centimeter, as you know the parameter of joining, right? And we'll take then these points 3 centimeter, the points at 3 centimeter will be of CD. So this point is C and this point is of. Now we will join these all points with the help of ruler. Line 1, 2,3, So this is how you will get your actual diagram, right? With the help of compass only. We haven't used the protector in this. I hope this is clear to all of you. So this is our required diagram. Yep. So moving to the next question. Next question is case. Case is a diagram, is a square that is given to you, as you can see here. The points U, V, W, X are the midpoints. You can see this of this square. What type of quadrilateral? This is very, very important question. This is very important. You need to find out what kind of quadrilateral UVWX is and find this by using geometrical reasons as well as by construction and measurement. Find other ways of constructing a square within a square such that the vertices of the inner square lie on the sides of the outer surface. Like this is one of a way, this is another way as shown in the figure B. You need to show how we can construct a square within a square, right? Square in square. They are asking for square in square only. Other ways of construction are square in square here, right? In the first question, you need to find out what kind of quadrilateral it is. It is square, it is rectangle, what is this? This is what the question. I hope you got the question. Okay, so this is what we have the diagram. So let's start now. As you can see, U, V, W, X, they are the midpoints. What are they? They are the midpoints of the outer square. Outer square is given, right? Now we'll choose some triangles. So what are these? These are triangle VCU, this one. Can you see this triangle? And triangle UAX, angle this. Clear? So in triangle VCU and triangle UAX. We are choosing these two triangles. Here, VC is equals to UA. This is equals to UA and angle VCU equals to angle UAX because they are of 90 degree. CU is equals to AX, right? As these are two triangles and we have three parameters, they are equal. CV is equals to UA, right? CU is equals to AX and angle C equals to angle A, which is of 90 degrees. So which criterion is given is following here. SAS criterion is following here. By SAS, those both the triangles are congruent to each other. So by CPCT, we get VU is equals to UX. We prove that with the help of congruency, VU is equals to UX. Similarly, if we use other pair of triangles, we'll get VUV is equals to XW and VU is equals to WX. We can prove all these sides are equal to each other. We can prove that the sides are equal to each other with the help of CPCT. The sides are equal. Now, which determine the interior quadrilateral is a square or rectangle, we need to find out the angles as well. We know all the sides are equal. That means one hint is given. It could be a square, but to be sure that it is a square, we need to prove that the interior angles, angle U, V, W, X, they are of 90 degree. Okay. For this purpose, what we'll do? Let's use triangle VCU. Triangle VCU, again this triangle. Here VC is equals to CU. VC is equals to CU, that means this angle will be equals to this angle. Let's say this is angle 1, this is angle 2. As these are equal, so angle 1 equals to angle 2 because opposite sides have equal angles. Equal opposite sides have equal angles. And this is angle C. This is angle C. Okay. And you know, in a triangle, the sum of all the angles, angle 1, angle C and angle 2, this is of 180 degree. And from here we get, if angle 1 equals to angle 2, you can easily find out twice of angle 1 is equals to 90 degree. So angle 1 is equals to 45 degree. If angle 1 is 45, then automatically angle 2 will also be of 45. And similarly, angle 3, if we'll take it angle 3, this is angle 4, they are also of 45 degrees. So similarly, angle 3 is equals to angle 4, they are also 45 degree if we choose this triangle AUF. So you get this also, okay? So now just look at this part, just this part. Will this. Just look at this portion. You know angle 2 is 45, you know angle 3 is 45. It is easy to find out this interior angle. No? So what I use here, linear pair. Okay. So angle 2 plus angle 3 plus angle U is 180 degree because they form linear pair. Okay. Angle 2 and angle 3 both are of 45, 45. So adding up to 90. Angle U is equals to 180 degree. So we get angle U is 90 degree. Similarly, by using the other pair of triangles, we get angle X, angle W and angle Y, angle V, sorry. They are also of 90 degrees. So here we are concluding this, that as all the sides are equal, this internal quadrilateral is having all the sides equal, all the angles are of 90 degree. So definitely this is a square. The interior part of this square, the interior quadrilateral of this square is a square itself. I hope this is clear to you, right? So for the B part of this question, we are taking the points here A, B, C, G, and the interior parts I'm taking it as P, Q, R. Okay. So as you know, square in square, that means we need to prove that PQRS is also a square, right? So take PQRS such that PQRS we are taking such that AS, AS, BP, QC and RD. Can you see that? The points AS, BP, QC and RD. They are equal. We take PQRS in such a way that they are equal. Since the sides of a square are equal, we have DS, AP, BQ and CR that is also equal. Why I am parting them? Because we'll use this portion in the congruency of the triangles. I'm just talking about these parts, okay? So these longer parts and these are the shorter parts of the sides. Okay? So now the choice of the triangle. Now choose a triangle. We'll choose the triangle PAS and triangle SDR. Two triangles PAS and SDR. Can you see that? This one and this one. These two triangles are to be chosen. And here, as you know, three parameters we need to find, right? PA is equals to SD, as just we discussed here, right? Angle PAS 90 degree is equals to angle SDR, again 90 degree, because they are the angle of outer square. Okay, and AS is equals to DR. The shorter parts are also equal. So which criterion is following? Again, SAS conditioning. Both the triangles are congruent. So by CPCT, we can say that PS is equals to SR. PS is equals to SR. Clear? So by using the other pair of triangles, we get to know that similarly, all the sides PS is equals to RQ also and PS is equals to QP also, which is defining that all the sides are equal of the interior quadrilateral. So now to prove the angle is of 90 degree, for this again we'll wisely choose the triangle PAS only, and in this triangle angle 1 and angle 2, this angle 1 and angle 2, angle 1 and angle 2, we'll choose these two angles and this is of 90 degree. All the three angles are summing up to 180. Angle 1 plus angle 2 plus 90 degree, they are summing up to 180 because by the triangle property, right? Angle 1 and 2 are equals to 90 and angle, let's erase something. This is angle 1, 2 and this is angle 3. Okay? Angle 1, 2 and 3. As we have proved both the triangles congruent to each other and angle 1 and angle 3 are equal by CPCT. So if angle 1 plus angle 2 is 90, then we can say angle 3 plus angle 2, this is also of 90 degree. If angle 3 and angle 2 are 90, so we can easily figure out this angle, and this is also of 90 degree by using the linear pair. And similarly, with the help of other pairs, you can easily find out that all the other angles are of 90 degree. Hence proved. So this is also a square. See, this is the vice portion here. Give me this one. This is the vice. This is a trick. This is not a trick. This is a magic here. The magic of congruency. I use this trick and get the link of 2 and 3, so that to find out this angle. Are you clear? So this way you need to use your brain and find the link to create the answer. Now moving to question number 8. Question number 8 is, if a quadrilateral has 4 sides and one angle 90 degree, will it be a square? Find your answer. Okay, so let's do the question number 8 now. A quadrilateral which is having all the sides equal. So we construct a quadrilateral ABCD such that all the sides ABCD sides are equal and one of the angle DAB is of 90 degree. We have taken this, right? So well done. I have done the little construction here. We joined BD in this uh, in this figure, in this quadrilateral. Now we need to prove that will it be a square. For square you need to prove all the angles, C, D and B all are of 90 degree. Clear? So let's do it. We'll choose the triangles in triangle ADB and triangle CDB. Can you see these triangles? ADB and CDB. In both the triangles, see, by SSS criterion, you will figure out why I have applied SSS criterion here. The triangles are congruent, and by CPCT, angle C is equals to angle A, which is of 90 degree. And how SSS criterion is applied here? Just check it out. Okay, do it yourself. By SSS criterion, I get to know angle C and angle A by CPCT, they are of 90 degree. So now in triangle DAB, can you see angle DAB? Triangle DAB. Here, angle 1 is equals to angle 2. And why this so? This also to be figured out of your own. Hint is AB equals to AD. The reason? Now I think you know that, right? Angle 1 and angle 2, right? And in this triangle, angle 1 plus angle 2 plus angle A, they are of 180 degree. That means angle 1 plus angle 2 is of 90 degree. If angle 1 and angle 2 is of 90 degree and they are also equal, that means the angle 1 will be of 45 degree, which is equals to angle 2. That means we know now angle 1 is 45, angle 2 is 45. And similarly, by using this triangle, you get angle 3 is 45, angle 4 is 45. Similarly, angle 3 and angle 4, they are also 45 degree with the same process. By adding 2 plus 3 and by adding 1 plus 4, you will get they are of 90 each. That means all the angles are of 90 degree. Yes, this is a square. Clear? Moving to the next question. Question number 9. What type of quadrilateral is one in which the opposite sides are equal? Justify your answer. Okay, where opposite sides are equal. So let's check it. You are given a quadrilateral where opposite sides are equal to each other, right? I have made a construction here, that is AC. Join AC. This is a construction to be done. Now the choice of triangles. You need to find out what kind of triangle quadrilateral it is. We'll figure it out soon. But for this, firstly, we use some congruency results. So in triangle ADC and triangle CBA, ADC and CBA, these two triangles are chosen, and by SSS criterion you will tell me how SSS criterion is applied here. SSS criterion, obviously these two sides are also given to you equal, right? They are congruent, and angle 1 is equals to angle 3, angle 2 is equals to angle 4 by CPCT. If they are equal, that means AC is a transversal line. AC is a transversal line. Transversal line. That means angle 1 and angle 3 are alternate interior angles, angle 2 and angle 4 are alternate interior angles. And we know the property, if AC is a transversal, they are equal and they are alternate angles. So the lines are parallel to each other. That means AB is parallel to CD. Similarly, AC transversal line is there, angle 2 and angle 4 are also interior angles. That means AD is parallel to BC from the same result. Okay, this is the result that we have done in the previous classes as well. So all the sides, opposite pairs are equal also, opposite pairs are parallel also. So what result is getting here? That is, it's a parallelogram. Okay, so the result is a parallelogram. That's all, I think. Nothing to do. We just prove the congruency of these two triangles, and with the help of CPCT, I just taken that angle 1, angle C, and angle 2 and angle 4. Moving to question number 10, that is, the sum of angles in a quadrilateral such as the following one also be 360-degree. Find the answer using geometric reasoning and figure it out. You are given a diagram here. Will the sum of angles in a quadrilateral such as the following one, this is also taken as one of the quadrilateral, also be 360-degree? This is the question. Okay, so let's check it out with some geometrical tools. So this is what we have the diagram in the question. We'll do a little construction here. We will join BD here. We will join BD and mark some points. This is angle 1, this is angle 2, this is 3, this is 4. We'll use some angles here. So let's do it. In triangle ABD, angle A plus angle 1 plus angle 3 all gives you 180-degree. And in triangle CDB, here's also angle C plus angle 4 plus angle 2 gives you 180-degree. Okay, adding both the statements. Adding, as this is one first statement, this is second statement, adding both the statements, you will get angle A plus angle 1 plus angle 3 plus angle C plus angle 4 plus angle 2 is equals to 360-degree. How 360-degree? 180-degree plus 180-degree. Okay, this is 360-degree. So, okay, now the angle 1 and angle 2, when we add them, we'll get angle D, right? Angle 1 and angle 2 giving us angle D, and angle 3 and angle 4 giving us angle B. That means angle A plus angle B plus angle C plus angle D. This is equals to 360 degree. Also, with the help of protractor, we can also find the sum is 360 degree. This is the answer of question number 10. Clear? So the last question of this chapter is question number 11. Question number 11 says, state whether the following statements are true or false. Justify your answer. First statement is, a quadrilateral whose diagonals are equal and bisect each other must be a square. First question is asked, a quadrilateral whose diagonals are equal, and say any quadrilateral whose diagonals are equal and bisect each other. That means diagonal equal and they are bisecting each other also, must be a square. So such quadrilateral is not need to be a square always. In this figure, the C A B C D, AC and BD are equal. AC is equals to BD, it is given, and if this is O and they are bisecting each other also, so the given statement is false. This is a false statement. Such kind of quadrilaterals are always rectangle. They are saying must be, na? So it is not always. It can be a. It is always a rectangle. This is the answer, proper answer. Yeah. Moving to the next part. Second, a quadrilateral having three right angles must be a rectangle. So if you having a quadrilateral, say this is a quadrilateral with three 90-degree angles, it must be a rectangle. Okay, this is true. This is true because with the why the property of a quadrilateral, the sum of all the angles of a quadrilateral is 360-degree, right? 90 plus 90 plus 90, 270. What should be added to 270 to get 360? Again 90. So fourth angle will also be of 90-degree, right? So yes, this quadrilateral is a must be a rectangle. This is true. Third, a quadrilateral whose diagonals bisect each other must be a parallelogram. So a quadrilateral, so let's take it as a quadrilateral whose diagonals bisect each other, that means this equals to this equals to this, must be a parallelogram. For this we need to check out is it true or not. Okay, so if they are bisecting, let's name this A, B, C and D, and say this is O, central is O. So we are choosing triangle AOD and COB. AOD, AOD and COB both are obviously congruent. If they are congruent, angle 1 equals to angle 2. What angle 1? This angle 1. This angle will be equals to this. Like 2. This angle 1 will be equals to angle this. Right? They are alternate angles. That means the lines are parallel. The lines are parallel. Clear? And similarly, if we use the other, we'll get this pair also equal, and we can say these two lines are parallel. So this statement is true. Yes, we are getting a parallelogram here. Must be a parallelogram. So this statement is also true. Fine. Now, fourth one, a quadrilateral whose diagonals are perpendicular to each other must be a rhombus. Uh, It could not be true. This is false. A quadrilateral whose diagonals are perpendicular may not be rhombus because the diagonals may not bisect each other. For rhombus, it should also be bisecting each other. Na? They are just saying perpendicular to each other. So this is directly false. Okay. Fifth one, a quadrilateral in which the opposite angles are equal must be a parallelogram. So if we have a quadrilateral, okay, say this is A, B, C, D, opposite angles are equal. They are saying opposite angles are equal. It must be a parallelogram. For this, we need to show a transversal line. Okay, this angle equals to this angle equals to this. So addition of all the angles is 360 degree. So let's say they are 1, 2, 3, 4. I'm doing this here, little in little space. Angle 1 plus angle 2 plus angle 3 plus angle 4. This is 360. Hmm? Angle 1 equals to angle 3, so we can take it as 2 times of angle 1. Angle 2 is equals to angle 4, we can take 2 times of angle 2. This is 360. So angle 1 plus angle 2, it is 180. Okay, yes. If angle 1 and angle 2 gives us 180, that means this is a transversal line, AB. Hmm? Okay. So AB is a transversal line of AD and BC, and the interior angles are summing up to 180 degree. That means AD is parallel to BC. Similarly, if 3 and 4, they are co-interior. So, sorry, 1 and 4 also co-interior. So, we get this parallel also. So, yes, this statement is true. They are parallelogram. Sixth part, a quadrilateral in which all the angles are equal. All the angles are equal is is a rectangle. So, this statement we need to prove. Say this is a quadrilateral, this kind of quadrilateral I'm taking. Okay, where all the angles are equal. That means when we add any all the angles like 1, 2, 3, 4, they are summing up to 360. Na? If all the angles are equal, that means angle 1 plus angle 1 plus angle 1 plus angle 1 is 360. So 4 times of angle 1 is 360. So angle 1 will be of 90. And all the angles are equal. That means all angles are of 90 degree. All the angles are of 90. If all the angles are of 90, then obviously this diagram is not possible. The diagram will be like this. All the angles are of 90. Now here to prove the sides, we'll use the help of a diagonal, and I'm giving hint here with the criterion ASA. We are already done in the previous questions. You need to prove all the sides equal. So the statement is true according to me. Okay, and how it is true, this is your homework. You need to figure out of your own. Last, seventh part, isosceles trapezium are parallelogram. No, this is not true. False. They are not parallel. In isosceles trapezium, there are two non-parallel sides which are equal. Okay, this is isosceles trapezium where two non-parallel sides are equal. So this could not be parallel. This is false. So winding up this chapter, Just go through with the summary. All the properties are given here. Okay, and just do in a good way. If any query, you can ask to me anytime. Thank you so much.